So of course, if you have, for example, a small mistake in one observation, it could lead to a very different, all different results. Yeah.
You changed it from comma to dot, or from dot to comma?
From dot to
It-
comma. So
it
everyone
depends.
is comma.
It depends on your settings you have in your Excel. Please, what I do is a very simple exercise. What I do in order to check what is the system behind my, for example, Excel, is just to build a sum of two numbers. Just do a sum of your FDI and tax rate. If you have the error like value, yeah, question mark or something like that, or hashtag, it would mean, okay, something goes wrong, and then you have to check whether dot or comma is the right way for you, because it's not, of course, the same for everybody. So, but let's assume everyone has a very close result to this one we have on the slide. And what do you think about our results? Are they a little bit better? Are they improved?
Yeah, it definitely improved. If we kicked out the outliner, we find it like the R, at least the R square, the number extraordinarily significantly increased.
Yeah, from 5% up to 12% or even 24%. So once again, in order to repeat it, so it means that a tax rate explains up to 24% of the variation of the FDI. Okay, that's actually a nice number. And?
Also, if the rates rise and the FDI actually drops from the formula, yeah, and that makes sense.
It's much more in line with our hypothesis, with our expectation, yeah? It, of course, if our result is in line with our expectation, it doesn't mean it's a right one, yeah? That should be also clear. But in this case, it's in line with our hypothesis, and we have, of course, to check R squared. And in a minute, we will explain that not this only value as the final one we should check. Once again, why that? Because R squared means that we have only a certain part of the deviation or variation of FDIs explained by tax rate, and it doesn't mean that there's no effect. There is an effect, but we have a bunch of other variables. Are important. Yeah. Okay. So once again, please could anybody tells me what is the interpretation for this equation? Just in one sentence, clear sentence that we repeat. The result for this equation. What is the interpretation? Yeah.
Doesn't it mean if we rise our tax rate by 1%, we will lose like 1.7055?
Yeah, 1.7%. Yeah.
Percent of our FDI.
FDI, our FDI by 1.7% of GDP, because we have to think about our unit of FDI, which are not, for example, billions of euro, but rather percentage of or portion of GDP. Yeah, okay. Right. And you could interpret it the other way around. If the question would be, what kind of recommendation could you make regarding tax policy if we would like to attract more FDI in our country? You wouldn't say, of course, yeah, if you would increase your tax rate, then you would say, we are calculating that if you will decrease your tax rate, for example, in Germany, by 1% decrease, then you would increase your FDI by 1.7% of GDP. Okay? That's clear. And what we had also in the other room as an important issue is that this result is, if we would say, okay, it's a sensible result and R squared is a high score and so on, but it's still just a result for a relationship between these two variables. Only because we selected this kind of equation, assuming that x is independent and y is dependent, yeah, it doesn't mean that we have indeed, by this model, this kind of direction, because this model checks just the most perfect line. We will explain it in a minute. Most perfect line for this model, and doesn't check this direction, whether that's the right one. It could be, for example, hypothesis would be, I would observe it and would say, no, I don't believe it. From my perspective, the story is that we observe FDI, and then having a low level of FDI, then we would decrease our tax rate in order to improve FDI. So in my story, FDI would affect tax rate and not the other way around. Okay, it should be clear. So at the end, what we see here, or if you will run a regression, you should be very careful, and you should actually make only this kind of statement. Yeah, this result, let's say, suggests very carefully. This result suggests that we have a negative correlation between tax rate and FDI. Okay, I didn't mean that this result means that the tax rate decrease FDI, because there's no confirmation for this kind of statement. Okay, but of course, if we believe in our story, and I believe it strongly, that the tax rate has some impact on FDI and not the other way around, then of course, I mean by that, I checked it, and my story is like that. It should be the right direction, but still, our program or our Excel or Stata in a minute just confirms this relationship, not the direction. And in order to repeat the whole content, we had just the other group. I will ask also the question whether you know what kind of model do we use, or whether you know already the abbreviation OLS. OLS. Yeah, yeah, right.
Is this abbreviation ordinary least square?
Yeah, ordinary least square. For squares, the sum of squares, we will calculate here, and you will understand it in a minute. So, if we have a question like this, or we would, for example, check what will be a reaction of our consumers to a product, so in order to stress this importance of this this method, it's not just a theoretical one, it's really applied in the real world. We collect what we are doing. We are collecting data. Facebook, Google. We now in this simple model, what we need are some observation. We need some data. And here we have some data on tax and FDI. Every particular dot is just, for example, in our case, a country with this tax rate and this level of FDI. It should be clear, yeah? That's our observation. And then, in order to make some prediction, and the prediction is how, for example, FDI will change if I will change my tax rate, because it's an interesting question, yeah, for a policymaker, for example. So we try to make some predictions, and for that, the common approach is to use OLS, so to calculate the squares. So what is that? At the end, we try to draw a line which is as close as possible to the whole or all observations we have here. So let's take red here, and using our Excel or Stata, Excel would say, yeah, the trend line, which is at the end, this line as close as possible to all the observations, would be like this. And that's our connection between tax and FDI. Okay? That's our relationship. So it means, okay, so it by accident, it's nice try. So we have, for example, here a perfect observation, which is perfect regarding our prediction. Because our prediction would be, if you have a tax rate of 20%, your FDI will be 50% of your GDP. And for one country, we have this observation, but it's just an accident, yeah, I would say. And then we have to, let's say, create this function. How to do it? We would like to pay attention, of course, to some deviation we have between our observation and the real world and our prediction. Our prediction is this function. The real world are these observations, okay? And for example, here I can see that's the real world, that's my prediction. So I have this deviation between a real observation and my prediction. Real observation, my prediction. Real observation, my prediction, and so on. And now the question is, how should I generate this function? I will try to generate this function once again in order to minimize these deviations, right? So I would calculate just the sum of these deviations and try to make it as small as possible. And now, the question would be, okay, but here, for example, if I would take the real observation minus the observation, my prediction, I would, for example, collect here, I don't know, 10. And here I would collect minus 10. The first problem. So if I will calculate my sum, then I would have some kind of equalization between 10 and minus 10, right?